This video is the first part of investigation on interferometer in microwave optics. We will use most basic components and configuration to perform the experiment. Here's the diagram of a Michelson interferometer. The two light rays with a common source combine at the beam splitter to reach the detector. For the beam splitter, we use the half mirror plate provided as default accessories of the microwave optics experimental kit. Let's see the experimental setup without the mirrors. The receiver shows no signal of microwave. A metal plate has been added as a mirror in the path of the transmitter. The receiver shows some signal of microwave. When the mirror is moved slowly away from the beam splitter, the signal strength on the receiver varies due to constructive and destructive interference. Now the metal plate has been moved to the path of the receiver. The receiver shows some signal of microwave. When the mirror is moved slowly away from the beam splitter, the signal strength on the receiver also varies due to constructive and destructive interference. Let's add another mirror in the path of the transmitter. We can use a vertically oriented polarizer because the transmitter is also oriented vertically. When the polarizer is moved slowly away from the beam splitter, the signal strength on the receiver also varies. The effect of constructive and destructive interference appear much stronger compared to when we only used one mirror.